Well, today's topic is just going to be all sorts of mixed review, and we've got a lot of tools in our toolbox at this point. And I'm going to give you about 9 problems. My suggestion is to copy the problem down, try it on your own, and then see if you got the answer correct. You know, if you did, you can kind of speed up through that part, and then try the next problem, see if you got the answer correct. So good luck, and I'll look forward to seeing you tomorrow. Question number 1, find the derivative. So like I said, pause it, put your answer down, and then hit play and see if it matches with mine. When I read this, I said this is the cosecant of, I wrapped it in parentheses, so I could clearly see my inside and outside. The derivative of cosecant, I know is cosecant cotangent, but remember it's keep the inside. So negative cosecant, keep the inside, cotangent, keep the inside, times the derivative of my inside, which is 30x squared. And lastly, always make sure you pull that negative and that coefficient out front, and you've got your answer. Question 2, find the derivative. Remember to rewrite it and read it out loud to yourself. Pause it, compare answers. So at this point, I just wanted to show my derivative and talk real briefly. I noticed I had product rule. I had this term times this term to the 1/3. So I said first left a blank plus second left a blank. When I took this guy's derivative, I said it's 1/3, keep the inside, to the negative 2/3 times the derivative of that inside, and then of course times 2x. Now remember, we've got to pull out a GCF. So again, if you've gotten this point and you're good, pause it, try that GCF, and I'll talk through it in a few moments. So real quickly, just checking my GCF, I kind of bracket this side of the plus sign and this side of the plus sign, and look to see what they have in common. I saw this quantity, and I'm always pulling out the smaller, so I pulled it out to the negative 2/3, and I also noticed they had an x in common, so I pulled that out as well. So you can see I crossed that off, and I replaced x squared with x, and then I just knew I had to multiply because it says times this times this times this is 8/3 x squared. Kept my plus sign. If you're not sure how much you have left, you take what you have, subtract what you pulled out. So here's my 1/3 minus negative 2/3. You always get 1, hopefully you've started to notice that, times 2. Again, I just wanted to focus on my cleanup here. I distributed and cleaned up inside my bracket. I left this x out front, and I moved this junk downstairs. Now, we talked about this last week in a few of the classes, and we said everybody has this gut instinct to move this 3 to the bottom because it says 8/3. Now, if there wasn't any of this nonsense here, any of these plus signs, that's totally legal. But because you have that plus sign there, you cannot do that. I cannot move this third to the bottom of all of these. They're all not divisible by 3. So here's what we do, and I'm just going to take this x and distribute it through. So I'm going to say this is really 8/3 x cubed plus 8x cubed plus 10x all over the cubed root of this junk. And I'm going to say because I can't move that to the bottom, the only way to kill this 3 is basically to multiply every term I have by 3. So this term by 3, this term by 3, this term by 3, and this term by 3. Again, I can't just move it to the bottom because of that plus sign. So that leaves me with, in the numerator, 8x cubed plus 24x cubed plus 30x all over 3 cubed root of 4x squared plus 5 squared. And lastly, I hope you would agree you could add these x cubes together. So I'm just going to cross it off on top and say that's 32x cubed plus 30x. And there you have it. Question 3, find the derivative. Again, pause it, see what you get. Before I pull up my GCF, I just wanted to compare derivatives. Notice you had product rule in there. It says x times that quantity. So first derivative of the second plus second derivative of the first. And again, when I talk through my GCF, I'm looking at both sides of the plus sign and pulling something out. So if you're good at that point, pause it, try your GCF, and finally compare answers. So I've got 3x plus 7 to the 4th times 18x plus 7. Again, find the derivative. Let me give you one hint. We haven't seen anything with a fraction inside our cosine. I just want to stress that rewrite step. Pause it, see if we get the same thing. So of course what I meant by that was you need to have a base to a power. So I rewrote this as 5x to the negative 1. Just move my x up. Have my inside and outside. Derivative of the outside is negative sign. Keep the inside. The derivative of the inside now is quite simple. Negative 5x to the negative 2. Lastly, as I clean that up, I just want to take note, a negative times a negative is a positive 5. This x squared can move to the bottom, and I'm going to keep my sign of 5 over x. Now, this one's not considered a complex fraction because this is inside of the sign. And there you have it. Number 5, find the derivative. Pause it, see what you get. Well, here's my final answer. I'll quickly run through my steps in case you did not get that. I just want to recall the derivative. I had to go with quotient rule. So I have low d high minus high d low over low squared. Switching these is not okay like it is in the product rule. And then my personal step is to distribute here, and then finally distribute this negative through. Combine my like terms, and you should get that answer. 6, again, find the derivative. Well, I hope you did not attempt quotient rule. We've talked about this before, so just, read carefully. That one term on the bottom is make like a beaver and split. Okay, and remember, you just divide every term by 5x cubed. So that's 1/5 x to the negative 2. This is 4/5 x to the negative 4. This is 8 over 5 x to the negative 5th. So much nicer than quotient rule and so much easier. Quickly take its derivative, so I get negative 2/5 x to the negative 3rd minus 16/5 x to the negative 5th minus 8 x to the negative 6th, and of course rewrite it. No quotient rule. All right, number 7. A couple more to go here. This time it says find the second derivative. Now recall we talked about that earlier in the week. Second derivative means obviously take 2. But in order to get the second, you have to get the first and then derive it to get the second. So take your first derivative, see if it matches mine, and then compare second derivatives. So of course I rewrote it as 12x to the 1/5, took its derivative to get 12/5 x to the negative 4/5. That is my first derivative. Now this is who I'm going to derive to get my second derivative. And I get, if I bring this down, negative 48 over 25 x to the negative 9/5. And lastly, of course, we know how we need to rewrite this. And notice I have that double prime because that is my second derivative. Negative 48 over 25, and this is the 5th root of x to the 9th. Now, let me just give you this little piece of advice. They could actually rewrite this as negative 48 over 25, of course. Now, how many times can 5 go into 9? Well, I would say it can go in once, so you can actually pull 1 out. And how many are left? Well, 9 minus 5 is 4. So I could say that is the 4th root of x. Okay, did you take note what I did? 5 goes into 9 once, so I could pull 1 completely out and have 4 left over. So don't be scared if you see something like that. Your math is right. You probably just need to clean it up to match their choice. All right, number 8. Again, find the second derivative. So I would rewrite it, take the first, see if it matches with mine, then take the second. Pause it, see what you get. All right, so you can see my first derivative, and before I take the second, I'm actually going to clean this up quite a bit. I'm going to say y prime is actually, I can multiply the 2, the negative, and the 4, so I can call that negative 8 cos of 4x, and then sine of 4x. Okay, so there is my first derivative. Now I need to take the second derivative. And if I read it, it says negative 8 cos of 4x, that's my first term, times the sine of 4x. Do you see product rule there? You have a first term times a second term. And remember, this 8 is just a coefficient, so I'm just going to wrap it up in that one. So why don't you pause it, try your product rule, and see if we get the same thing. So I said it's the first term, left it alone. Derivative of the sine of 4x is cos of 4x times 4. Kept the second. Derivative of this guy is the cosine becomes positive or negative sine, which makes this a positive then. So positive 8 sine of 4x times 4. And again, I'm just going to clean it up, and I could pull out, oops, no GCF, so I'm just going to rewrite it as y double prime equals 8 times 4 is 32. So again, I can multiply this term and this term, so I've got negative 32. Notice I have cos 4x and cos 4x. I can say that's cosine squared of 4x because I have two of the exact same thing. And on this one, I get positive 32. And again, I've got sine of 4x times sine of 4x, which is just going to be sine squared of 4x. And there you have it. Well, it is that time of the night. We have made it to the last problem of the evening. So I can't stress enough before you take this derivative to read it out loud. And in fact, I'm going to read it with you. It says y times cos x. There's a product rule. I have negative 4x times y. There's a second product rule. So pause it, see if our derivatives match, and if you found yourself successful tonight, you are in great shape for our test this week. So here's a piece of my product rule. If that matches, then like I said, you're most likely in good shape. I'll work through the rest of it and we can compare. But first derivative of the second plus second derivative of the first, that y turns into dy dx. So every time you see a y, you should say to yourself, I need at least 2 dy, not at least, I need exactly 2 dy dx's in this problem. Kept my negative 4 out front, first derivative of the second plus second derivative of the first, and go ahead and see if your cleanup matches mine. And here is my final answer. Remember, it's equivalent if you had the exact opposite as well. If you had negative 4y minus y sine x all over 4x minus cos x. That is also equivalent if you switch out the signs. Well, like I said, have a great night, and we'll see you tomorrow.